I again welcome you to the class, and in this class we'll be talking about the moment of the disk about the an axis passing through point O. Well, in the previous class we discussed two important things. First one was the angular velocity of the disk with respect to the ground frame of reference. Let me today write it angular velocity of the disk with respect to the ground as omega disk with respect to the ground, and the expression for it was that one we had derived. It was minus phi dot sine theta I cap sine theta I cap plus theta dot j cap plus theta dot j cap plus phi dot plus psi dot plus phi dot cos of theta k cap. This is it. And we had also obtained the angular velocity of the rotating frame of reference, angular velocity of the rotating frame of reference with respect to the ground frame of reference, as it was equal to minus phi dot sine theta I cap plus theta dot j cap plus phi dot cos theta k cap, cos of theta k cap. Okay, now we know from the property of derivatives that as far as the moment is concerned, the equation for the moment is concerned, the equation for the moment is that is summation of all the moments about an axis passing through point O. Okay, it's equal to the derivative of d by dt of summation of all the moments about an axis passing through point O is equal to the rate of change of the angular momentum, that is d by dt of h naught with respect to the ground frame of reference. Fine. And the expression for our h naught is, if you recall, the expression for h naught is, we have I prime. I will write here. Here we also have I prime, and here we only have I. This is, rest is fine. Okay, this is the expression for the, this is the expression for the h naught angular momentum, which we had previously derived. Now, as we went on to differentiate it with respect to the ground frame of reference, we can write using the property of derivatives as this is equal, okay, this is equal the derivative of, that is h naught, derivative of the angular momentum with respect to the rotating frame of reference, that is small x, small y, small z. We are calculating the derivative of angular momentum h naught defined in rotating frame of reference, small x, small y, and small z. Okay, with respect to the ground frame of reference, that will be the derivative of h naught with respect to the rotating frame of reference plus angular velocity of the rotating frame of reference with respect to the ground frame of reference, its cross product with the h naught. Okay, this is how we use the property of derivatives, and we know this expression. Therefore, summation of all the moments m naught is equal to the derivative of h naught. Our h naught is this expression. Okay, and we are assuming that our moments of inertia are constant terms. Fine. Therefore, the derivative of this h naught will be the derivative of h naught, the first term, it will be minus I prime. The derivative of sine theta is theta dot. Okay, differentiation of sine theta is cos theta. Okay, d by dt of sine theta is cos theta, and the derivative of angle, that is certainly that is going to be the what you call as uh, the theta dot. That's what we are writing. This is I cap plus then I prime again. Then we have theta dot, that is derivative of theta dot will be theta double dot along j cap. Then we have plus, okay, we have plus psi dot. First, the derivative of psi dot will be psi double dot, psi double dot plus phi dot cos theta. So these are actually both the, we have to take the derivative with respect to time for this and this term as well. Okay, so you will be using the formula of UV. First will be U, and the derivative of cos theta, that is theta dot. Derivative of cos theta will be minus sine theta. So I will write there as minus sine theta. So this will be here minus sine theta. Fine. So this is mine. And second term will be plus, so this is u into derivative of v plus v into derivative of u, that will be phi double dot derivative of and the cos theta. Okay, this will be along k cap. Fine. So this is the first term. Second term is angular velocity of the rotation, that is minus phi dot sine theta I cap plus theta dot j cap plus phi dot cos theta k cap plus cos theta k cap, and its cross product with a big term. The cross product is to be taken with, I will write the term here, the cross product with h naught, that is minus I prime phi dot sine theta sine theta okay, plus I theta dot j cap plus I psi dot plus phi dot cos of theta k cap. It's an expression. A little correction is here, because once we are taking the derivative of phi dot sine theta, here we also have to use the UV formula. Okay, so there's a little correction here. So it will be, you will have one more term here. So it will be phi dot differentiation of sine theta. Okay, we are having, it will be phi dot. So I need to correct this term first. This is not correct. So it will be minus I prime minus I prime. Then we have phi dot, and derivative of sine theta is cos theta, theta dot. So it will be theta dot, and derivative of sine theta is cos theta I cap. Okay, and one more term plus, since we have minus here, that's minus I prime derivative of u, that is phi double dot and phi double dot sine theta and I cap. Okay, so these two terms are in this. So we are having an expression now. So this is the derivative and this is the cross product. So this, what you will be doing, you separate the terms, you separate these all terms, take you take the cross product, write I, j, k, then write the components of I, components of j, components of k, components of I, components of j, and components of k, and take the cross product. The final equation that you will obtain, which I am leaving as an exercise, this cross product, because it will help me in saving the time. The final expression that you will obtain, and you should, it will be summation of all the moments about point O is equal to minus I prime phi double dot sine theta plus twice theta dot phi dot cos theta plus I theta dot psi dot plus phi dot cos theta plus phi dot cos of theta I cap plus I prime theta double dot minus psi dot square minus psi dot square sin theta cos theta sin theta multiplied by cos theta plus I phi dot plus I phi dot sin theta multiplied by phi dot plus psi dot cos theta along j cap along j cap. This entire term is along j cap, so I will put a brace over here. This along j cap. Same is the case here. This entire term, so write this as I cap. Plus the last term is I d by dt of I into d by dt of phi dot plus psi dot cos theta. This is along k cap. This is the final expression of the moments that you will obtain once you will take the cross product. So I'm requesting students to take the cross product themselves because it's saving me a little bit of time. And finally, I'm reaching to this expression. Okay. So if students find it a bit botheration in or find some problem in taking the cross product, they can contact. Otherwise, the cross product is quite straightforward. And final expression that we will obtain, it's this expression. And this expression is the expression that describes the motion of the gyroscope. So motion of the gyroscope is described by this expression. Now we have to talk about this expression because there are little problems in this expression that makes its solutions very complicated, and it's not possible to solve this equation by hand because there are some restrictions or some problems of non-linearity in this equation, which we will talk in the next class. But reaching to this equation first of all is very important, and it's a milestone for the students to reach to the equation of the gyroscope. We'll talk about it hopefully in the next class. Thank you.